Hey, it's Phil from Euroheat, and today I've brought you to a project in City Beach in Western Australia, where we're actually completely gutting and rebuilding a plant room. So this house is about 2 years old. The clients moved in about 2 years ago, and they selected another company to build, install, design their geothermal heating and cooling system for their nice house in City Beach. Now, for the last 2 years, the previous company has been trying to get the system to work because it's never worked, and the customer's been unhappy. There's been problems with the previous company, the contractor, and the supplier of the equipment, sort of pointing fingers, blaming each other. And basically what's happened is the clients had enough and said, everyone get lost. And they've called us to come in, and we did an assessment, and we actually found out that there was a lot of problems, but I'll talk to you about the three main problems right now. So one of the problems was that there's a lot of valves which move, which divert water either one way or another way, or they might mix water, say sending 70% of the water this way and 30% of the water that way for, to regulate temperatures or to send the exact amount of energy we need somewhere. And what we found was that here, even though a good brand of valves were used, either the wrong type were used, because there's lots of different types which they all have specific functions, and they were actually connected in the wrong way. So let's say there's three-way valves which send water different ways. There's one way which there's one port of the three-way valve, which is a common or a constant port, and the water always flows through the same way through that valve. And then the other two are the variable ports, which change. So this company had, for example, if this was the constant port, had connected one of the other ports as the constant port. And what that means is that the valve can't actually mix properly. It's either sending it thinks it's mixing it, say 70-30%, but it's way off because it's got a special disc inside which determines the flow rate through each port of the valve. So first of all, that wasn't working. And what that means is that the energy was never going to the right places. So we found, for example, that here, the heat pump is producing hot water and cold water simultaneously. When it was trying to get rid of, let's say, hot because it had no use for it, what was happening was it was supposed to divert that to the bore, to the ground connection. And what was actually happening was that the three-way valve was sending it into the cold water. And so the cold and the hot water were mixing. And basically, all the energy that was being produced was being lost, and nothing was happening at the end of the day. Now, the second, one of the second main problems that we found was the control system. And so what I mean by the control system is there are many valves, like we just talked about, that need to be controlled. There are heaps of sensors, temperature sensors in the plant room, around the house, to determine how much energy should flow where. Now, the control system here was, to put it crudely, it looks like it was done by someone that hadn't done this before. So there was a lot of flashing lights and it looked good, but it actually wasn't fulfilling its purpose. So when, let's say, the pool was calling for heat, there was no heat going to the pool. When the floor cooling manifold was supposed to mix, it wouldn't actually mix as it was supposed to send the exact right temperature water to the floors so that condensation doesn't form on the floor. So that was a massive problem. So that was another reason why a lot of things didn't work, because they just weren't being told to work in the right manner. And the third main reason why we found that the system didn't work was there was a lot of engineering design errors. So when you get the equipment from the supplier, they might provide you a schematic or a design saying, this is how you put all of our equipment together. And so that's what happened here. And actually, that part of the system was, when you looked at all of the pipes, even though it was a bit, all over the shop, when we traced the root of all the pipes, they were connected to the right parts, to the right ports of the tank, to the right ports of the heat pump. That was all fine. But then when you go past the tanks, so it goes to the pool heating or the domestic hot water or the floor heating and cooling, The size of the pipes, the size of the pumps, the way that the circuits were designed, they're all a bit off, which meant that some of the pumps had to be oversized. So you had huge, massive pumps that where you would normally use the smallest pump you can buy. That puts a lot of stress electrically on the system, and then also on the, say, velocities and flow rates in the pipes, so the pipes can wear out faster. But it also meant that a lot of things actually didn't work as they should. So can't get the flow rate that we require to, let's say, the pool. So when we've redesigned the system and repiped it, we're stuck with some of the old existing pipes that go from point A to point B. And because we can't get the but we want to keep it within the velocity, which is safe for the pipe, means that it won't wear out or make noise. We've had to, say, increase the temperature. And a side effect of that is that, yeah, sure, the COP or the efficiency of the heat pump lowers a little bit, but for the longevity of the system, this is the best way to go. We're about 90% of the way through rebuilding this system, and you can see that there's some German equipment over there, which is actually really high quality. That was the initial equipment that went in. And it's actually an interesting point that you can buy all of the right equipment, the best equipment, say, available on the market, but it doesn't guarantee that you're going to have a functioning system, because you need to put all of the components together. And let's say these suppliers, they supply one part of the system, and then there's other parts of the system. And it's sort of like saying, well, I'm just going to buy the engine from a Tesla, and then I'm going to try and put all the other parts together myself. Well, if you don't really know what you're doing with all the other parts, sure, you've got a Tesla engine, but is it really an electric car? Is it going to work? Is it going to make it to Margaret River or wherever you want to go? Probably not. So all the piping's been redone. The team are here now doing the controls and the electrical, so that'll be done soon. And the next step here is clean up and then insulate all of the piping so that we minimise any heat losses. We don't get condensation on the cold water pipes, and we'll go from there. Actually, and I've just remembered one more major mistake here. So this is an open loop system, which means that in Perth, we're quite lucky. We've got groundwater, which we can access and use that as the energy source. So in this part of Perth, even though there's groundwater almost everywhere, the quality differs a lot. And unfortunately, in this part of Perth, the groundwater quality is not very good. So what that means is when you bring the water up and you want to either strip energy from it or dump energy into it, the quality of the water affects all of the pipes and the pumps and the parts on the way. So here, there's actually iron oxide bacteria in the groundwater. And when that comes up and it is in contact with the air, it starts multiplying and it creates this like orangey brown sludge, which just, ends up filling up the pipes, filling up the heat exchanger, meaning that the flow rates are reduced and a lot of maintenance is required. So for this project, ideally, they should have used a closed loop system, which would mean that there'd be no maintenance. It would be a bit more expensive, but zero maintenance, and they wouldn't have this issue. So for this system, the client paid the previous contractor that the geothermal heating and cooling system a six-figure sum. And unfortunately, it hasn't worked in the 2 years that the client has lived here. Now the client has engaged us to get it working again, and we'll do everything we can to get it within the limitations to get it working as well as we can. And we will have it working to, let's say, 95% of if we were to build it from scratch. We'll get it really close, but we won't be able to get it the whole way because there's just some limitations from the previous contractors which we have to stick with. But this is often we get asked, well, Phil, how come Euroheat costs, let's say 10% more to build or this geothermal heating and cooling system? And the answer is quite simply because you avoid this. So because we have the experience, we have the engineering know-how, we have the relationships with all the suppliers, bore drillers, everything that we need. We have 20 years of experience with this, and we know exactly how much time and money and effort goes into building like this. So I would suggest if someone comes to you with a lower priced system, they either have missed something out, they're cutting corners, they haven't done it before, and they're sort of hoping for the best. And these are all things you want to avoid, so you don't end up in a situation like this, basically paying for the system, not twice, but paying another large sum to get it right.